Welcome to Plasma Discharge and Materials Processing class. I'm the teacher of this class. Okay, at the beginning of the class, I will show you the class contents and the schedule for this semester. So our class is the Plasma Discharge and Materials Processing. So at the beginning, I will let you know the concept of plasma and what is the plasma and how we can generate plasma. So the first part of the class is the nature of plasma, and then the ways to generate plasma by the DC power, RF power, and microwave power. Okay, so at the first 8 weeks, this class contents focus on the nature of plasma and the discharge process of plasma. So these parts are fundamentals and little bit theoretical. Okay, and then plasma is known as the fourth states of matters, and in order to categorize a plasma, we need to know the plasma density and plasma temperature, electron energy, and etc. So in order to characterize these properties, one can use electrical probe or Langmuir probe. So at the 9th and 10th week, the class will teach the electrical probe to analyze plasma and to get the plasma properties. And the other part of the class focus on the processing of materials. So after we know the fundamental and theory of plasma and the hardware and equipment for plasma generation, we can use plasma for our materials processing. So in industry, people use plasma to deposit thin films, to etch materials, or to make surface treatment of materials. So in our class, I will let you know the ways to deposit thin films by plasma processes. And one major plasma deposition process is based on plasma enhanced chemical vapor deposition. So in the 11th and 12th weeks, the class focused on the plasma deposition process, and then by plasma enhanced CVD process. And the other type of the plasma deposition process is named sputter deposition. So in the 12th and 13 weeks, the class focused on the sputtering technology and how we can use the sputtering to deposit metallic films, oxide films, nitride films, and even metal sulfide films. So the industry, including the electronic industry, mechanical industry, and some environmental applications, people need to make coatings by this plasma technology. Okay, and in the 14th to 16th week, the class introduced other applications of plasma. So including the PDP, plasma display panels, and discharge in liquid phase. discharge in electrolytes. And usually the plasma, in order to generate plasma, one needs to control the atmosphere and the pressure. And in the DC and RF discharge chapters, we focus on the plasma generation in low pressure conditions or in a reduced pressure conditions. But nowadays, people also design a system so that the plasma can be generated in atmospheric pressure, it's 1 atm pressure, or little bit lower than 1 atm pressure. So the class will also introduce the updated atmospheric pressure plasma and other new plasma technology. Okay, so the class is basically divided into 4 parts: the nature of plasma, discharge of plasma, and plasma depositions, and additional applications of plasma. Okay, and the class materials came from several references books. So these books are reserved and can be read at the library. So including the first book is Glow Discharge Processes, and this book focused on the sputtering and plasma etching technology. The second reference book is the Plasma Science and Technology, and this book focus on the plasma enhanced chemical vapor deposition technique. And also we can find the class materials from the Handbook of Plasma Processing and Technology and Principles of Plasma Discharges and Materials Processing. Okay, so class materials comes from these 4 books and some technical handouts or technical papers. And there's one midterm and final exam for this class. So the midterm is 50% of the score, and the final exam takes up the 50% of the score. And in the class, after you learn the basic plasma concept and the discharge processes, and you can come to my lab to see the sputtering system and the plasma and nitridation system. Okay, so there are 2 lab tours. So the lab tours are arranged in the 12th week and the 14th week. So it's arranged on December 12th and December 21st. Okay, and there are 18 weeks for this semester, but the final exam is at 16 weeks. So there are 2 weeks left after the final exam. So I will give you papers to study. So the papers of the plasma technology or plasma applications or the fundamental of plasmas. Okay, so my room number is at Engineering 1 building, the 3rd floor. Room number is 302-1, and here's my email. So you can reach me by just come by my office or send an email to me if you have any questions about the class, and if you want to discuss more or deep content of the class, you can come to my office. And because of the pandemic, the COVID-19 issue, the class will be held remotely in the first, second, and third weeks. So this class will be recorded, and then I will put the class video to YouTube, and you can access the YouTube by the access the code. I will announce the access code to the Moodle systems. You have to keep close watching the Moodle system to know the access of each hour of the class. Okay. So our class focused on the plasma discharge concept and plasma discharge theory fundamentals, and then the materials processing by the plasma technology. So at the beginning, we need to know what is plasma. Plasma is known as the fourth state of matter. So when we were high school students, or when we were just undergraduate students, we might know there are three states of matters, or three states of substance, namely solid state, liquid state, and the gas state. But if you heat up the substance to very, very high temperature, the gas molecule or gas atoms will further ionize to an ionized state, and this state is called plasma state. And plasma is composed of the ionized cations, right, and electrons and some other particles. Okay, so at the beginning of this class, I will go through this part and let you know what is plasma. Okay. We might thought we don't often see plasma in nature, but actually there are plasma on Earth. So the upper right figure shows a flashlight or lightning in nature. So lightning is one kind of plasma occurred naturally. The plasma of the lightning is composed of very high density of electrons and ions, and it is also known as arc in plasma. Arc. So there are different kinds of plasma. Arc is a very high density plasma. So we might see the lightning before or during a thunderstorm. So the lightning can exist in clouds or between the cloud and the surface ground. And once the lightning occurs, the electrical current can flow through the cloud and the surface ground. So we know that in the plasma there are electrons and ions which can conduct electricity. Okay. So we don't often see a plasma on the Earth, but sometimes we can see lightning, which is one type of plasma. Okay, and And just from this slide, we have already known that there are 4 states of matters. And on the Earth, we often see a solid, a liquid, and a gas states. Okay, so plasma is rarely seen on Earth, but in the universe, plasma is the major state of matter. Plasma is the major state of matter. So, in other words, the Earth or the planets can be considered as the supercooling state. But in the universe, the normal state is plasma. Okay, so if we look up to the air, we can see the sun. The sun can deliver energy to the surface of the Earth. So one can use this energy for different applications. So for example, if you have a solar cell panel, the solar cell panel can collect photon energy from the sunlight and convert the photon energy into electricity. Okay, so we know that the sun can deliver photons to the Earth. Okay, also the sun can radiate electromagnetic wave. And on the surface of sun, there is a layer of corona plasma or solar plasma. Okay, so here said the space surrounding the sun is a corona, is a plasma, and indeed much of all the space is occupied by plasma, and this plasma are in dark current mode. So in other words, this type of plasma has very low electron density. Okay, so inside the sun, there are nuclear fissions and nuclear fusions. So this type of reactions could generate enormous energy. Okay, and at the outer surface of the sun, there is a layer of corona, and corona is a weak plasma, okay, low density plasma. And the corona surrounding the sun, and sometimes the sun will also generate a burst of solar winds, a burst of electromagnetic wave, and a burst of the ionized particles. So these particles or these radiations could travel for a very long distance, and arrive the surrounding of Earth. If these radiations and high energy particles comes all the way to the surface of the Earth, this high energy species will kill the creatures, kill the plants, so that there is no life exist on the Earth. But since there is also electrical and magnetic fields surrounding the Earth, so that the magnetic field will repel or change the direction of these radiation particles, so that these high energy particles will not collide the Earth directly, but they will change their direction, change their directions. Okay, so as we know, the charged particles are known as the plasma. Or charged particles including a mixture of electrons and ions. Okay, they form a plasma state, so that the surface of the Earth is also surrounded by a layer of plasma. This is what we know. So in the universe, plasma is the normal state, and the Earth is a supercooling state. So there are not much plasma on the Earth, but the Earth is surrounded by a layer of weakly discharged plasma. And also on the Earth, we might see the lightning in a cloud or between cloud and the ground. Okay, so this is what we know, that they are naturally occurred plasma. And the left figure is a man-made plasma system. So right now, nowadays, people can set up a system and then make the electrical discharge of gas to generate plasma. So these bright parts, including the white and the blue luminous parts, are the plasma. Okay. So from this figure and from the lightning, we can know once plasma is generated, plasma also emit light. So that the plasma is composed of photons, electrons, and ions, and also neutral particles. So plasma is a mixture. And since they are different species or different particles, we need to know their ratio, their compositions, and use this to characterize plasma. So there are different kinds of plasma. So the left figure is the low pressure plasma, and this kind of plasma always have low electron density. Sometimes this type of plasma is also named glow discharge. And the lightning is known as arc plasma. And arcing is a very high density plasma. So there are high density plasma and low density plasma. And later on from this class, we can also know that there are high temperature plasma and low temperature plasma. So based on these properties, people can use plasma for different applications. So on the surrounding of the sun, there is the corona plasma. And at the center of the sun, there are nuclear fission process and fusion process. Okay. Nuclear, so right here, the slide shows the nuclear fusion in the sun. So the fusion means the small species or small particles, when they collide, they can merge to a larger particle. This process is called fusion process. So for example, when two proton and proton collide, collide, they might form a deuterium. So the atomic number or the atomic weight of the deuterium is 2, and atomic number and atomic weight of proton is 1. Okay, so the deuterium has a larger size than the proton, but during the collision process, two protons collide together. They will also release electron and emit enormous energy by loss of a very small amount of mass. So based on the equation E equal to m times c squared, the loss of mass will convert to energy. So two protons collide to form a deuterium, and one proton and one deuterium collide and fuse together to form a tritium. Okay, and if this process keep going, the tritium collide together, they might form helium atom. Okay, and all this fusion process, will lose small amount of the mass, and for deuterium collide with the tritium and form the helium and neutron, the loss of mass will generate an energy of 17.571 mega eV. eV is electron volt, is a unit of energy. Okay, so the energy will be released by the fusion process. So this energy keep the sun look like a burning for billions of years, keep burning. Okay, and the energy can also heat up the gases to form a plasma state near the surface or surrounding the surface of the sun. So the sun is surrounded by a layer of corona plasma. Okay. And the Earth is also surrounded by a layer of plasma, which is known as ionosphere. Okay. And since the fusion process in the sun can generate a very large amount of energy, so people try to run their fusion process to generate electricity, generate huge amount of power. So here is a nuclear reactor. So the left part is a schematic of a nuclear reactor, and the right part, the right figure, is a picture of a nuclear reactor. Okay, so from this picture, we can see here is an engineer working to repair a part of the chamber wall for the nuclear fusion reactor. So from this picture, you can see the size of a nuclear fusion reactor. So in order to run a nuclear fusion, one can flow hydrogen inside the reactor and use the electrical power to start the plasma and let the hydrogen atoms or collide, or let the hydrogen ion or protons collide to each other with very, very high energy. And this collision will undergo the fusion process. Just like the fusion process at the center of the sun. Okay, the fusion process from two proton to deuterium to deuterium and to triton, and then the collision, the final product is helium, and this process will generate an enormous amount of energy. So the nuclear fusion reactor is one type of plasma reactor which can generate enormous amount of energy, and this type of plasma is known as the high energy or high temperature plasma. So when the fusion reactor runs the reactor from the windows, we can also see the plasma glow. Okay, so this is one type of the plasma reactor. And the left figure here is the plasma reactor used in industry. So this type of plasma is low pressure plasma and also known as low temperature plasma. So one can use this type of plasma to make thin film deposition or etch materials. Okay. So there are different types of the plasma and different types of plasma reactor. And our class will focus on the low pressure plasma, because it can be built up in lab and in industry easily, so that you can use just one power supply to generate plasma. And the other type of reactor, plasma fusion reactor, is used for electrical power generation. So they use the high temperature plasma. And for the high temperature plasma, the temperature can reach few thousands to tens of thousand Kelvin or tens of thousand degree Celsius. And for such high temperature, all the materials, when they touch or when they are placed inside the plasma, they will not just vaporize, they will form the plasma state. So one needs a special technique to build up the plasma fusion reactor. Okay. But for the low pressure plasma system or the low temperature plasma system, one can use a stainless steel or glass cylinder or glass bell jar to make a plasma system. So it's easy to build up a plasma system, and it's widely used. The low pressure plasma is widely used in industry and in the laboratory.